Good morning, students. Let's continue the chemical kinetics chapter. The first video already given regarding the rate of a reaction. Today the topic is factors affecting the rate of a reaction. Factors affecting the rate of a reaction. There are mainly three factors affects the rate of a reaction. Number one, concentration. Number two, temperature. Number three, catalyst. Concentration, temperature, catalyst. These three factors affects the rate of a reaction. First one, let us discuss about the effect of concentration. See, effect of concentration. One by one I will tell you how, see how the concentration affects the rate of a reaction. Generally we know the concentration of reactants increases, the speed of reaction also increases. More the concentration of reactants means more number of molecules are available. That's why the molecules react faster. That's why the product also forming quickly. So it is observing that more of the reactions are showing that more the number of molecules are present, more is the speed of reaction. Based on that, what they are saying is the rate of a reaction is directly proportional to concentration of the reactants. So more the reactants concentration, more will be the speed of the reaction. Why speed will be more? More number of molecules are there means more collisions are going on between the molecules. The collisions increases the energy of the molecules. These points will discuss in the collision theory also. So more the number of molecules are there in the vessel, more bombardments, more collisions are going on. That's why the energy of the molecules increases. Energy increase means yes, they are readily forming products. So this is the reason. So that's why the rate of reaction is directly proportional to concentration of the reactants. This is generally happens. So for example, see example A I am taking. Suppose see A gives products. A gives products. How to write the rate expression? Its rate depends on the concentration of the reactants here also. It means the rate is directly proportional to molar concentration of the A. Molar concentration of reactant A. The molar concentration of reactant A means more the concentration of the reactants, more will be the speed. Here C means concentration. Here square root of A means here I have taken as concentration. If you remove this proportionality, you have to keep some constant, that is K into molar concentration of A. So this is the way of writing the rate equation. This is called rate equation. Rate equation. The way of writing this is called rate law. Rate law or rate equation. The rate law or rate equation gives us the relation between the rate of a reaction and molar concentration of the reactants along with the rate constant. Here K means rate constant. So the rate law gives us the relation between rate of a reaction, molar concentration of reactant and rate constant. So relation between all these three gives rate equation. The way of writing this rate with respect to the rate constant and the molar concentration of reactant is known as rate law or rate expression. Rate law or rate expression. This is, we can also write in another way also. The rate means, I told you, change in concentration by change in time. So this is, we can write like this, minus dA, देखो, minus dA by dt equal to K into molar concentration of A. Like this way also we can write. See the rate equation we can write like this. See this, minus dA by dt, minus dA by dt equal to K into molar concentration of A. Like this way also we can write. Means the R means how to write the R, I told you already yesterday. Change in the concentration by change in time. Why I have written minus here? Because the reactant concentration decreases. So minus we can write here. So the rate we can write in the form of R like this also. So I will give different example also. See, example changes means the equation also may changes. If example changes, equation also changes. See, next example. Suppose I have taken here A gives B. Now example B. Suppose A plus B gives products activity is given. General form is given. A plus B gives products is given. Then how to write the rate law, rate expression, how to write? So the rate is directly proportional to what they are saying, molar concentrations of the reactants. Here reactants, two reactants are there. So then how do you write? According to law of mass action in the class 11 chemical equilibrium. So there also we have written rate of forward reaction is directly proportional to molar concentrations of the reactants to their active masses. Means their coefficient raised into their powers. Like that, here whatever the coefficients are there, वो coefficients power में आ जाएगा, and the product of the molar concentrations of the all reactants also. Means the rate is directly proportional to product of A and B concentrations. Like this way we can write rate expression. So just you remove the proportionality here. If you remove the proportionality, R equal to K into concentration of A into B. So this is the way of writing the rate equation for the given reaction. Rate equation for the given reaction we can write like this. This means the rate law, this is called rate law or rate equation. It gives us the relation between rate of reaction and molar concentrations of reactants and rate constant. This relation it is giving. I'm giving another example. See, suppose 2A plus B gives products is given. 2A plus B gives products. How do you write the rate law for this? So in this case, the R rate directly proportional to product of the molar concentrations of the reactants to their powers. Means the powers are raised into their the coefficients are raised into their powers. So it will be molar concentration of A square into molar concentration of B will come. Just to remove the proportionality. So R equal to K into concentration of A square into B will come. So this is the way of writing the rate there. So this type of rate equation we can write. This rate equation we can use to solve some type of question. Suppose see, if A concentration gets doubled, then what will be the rate of the reaction? Yeah, when concentration is increases, rate also increases. See, in this case, if we concentration of A, if concentration of A gets doubled, then what happens? Rate also gets doubled. Suppose if concentration of B gets half, then rate will be half. Suppose if concentration of A gets 3 times and concentration of B gets doubled, then how many times rate increases? This is 3 times, this is doubled. So 3 2s are 6. So 6 times rate increases. This type of questions are there. Suppose see, in this case, if A gets doubled, B also gets doubled, then rate of reaction increased by how many times? A gets doubled means 2 square 4 times and B gets doubled only 2 power 1. So what happens now? 4 2s are 8. So 8 times rate increases. So this type of questions are there. Very important model questions always. If A gets doubled, B half, then if A gets doubled means 2A square, so 2 square 4 and B half, so 4 by 2, 2 times only rate increases. So like this type of questions are there in object 2 and subject 2 also. So this rate equation based questions always. So this is the way of writing the rate equation and the rate law also. After this topic, now I will give another concept, very important one, order of a reaction. See, all these are depending upon the concentration only. First factor affecting the rate of reaction only I am explaining. Factors affecting the rate of reaction may three types: concentration, temperature and catalyst. First one only I am explaining. All these are the subcategories of the concentration effect only. Now order of reaction. See, the order of reaction, how to define. To understand, I will give this explanation series. Suppose if I am taking, it is 2A plus half mole of B gives products. 2A plus half mole of B gives products. I am giving general explanations. Equations also we can take. Means direct actual chemical reactions also we can take. So for them also the same concept we can apply. So 2A plus half B gives products. So for this write the rate equation. The rate equation R is equal to, directly I am writing, R equal to K into, now I am writing directly, I am not writing proportionality. Finally I am writing R equal to K into molar concentration of A square, this coefficient power में जाएगा, and molar concentration of B power half. A power 2, B power half, because whatever the coefficients are there, coefficients power में raise होगा. This is the way of writing the rate equation. Okay, we learn up to this. Then what is the order of reaction? Order of reaction can be defined as, it is the sum of the powers of the concentration terms present in the rate equation. Yeah, this is the rate equation. In this rate equation, whatever the concentration terms are there, the concentration terms powers are there, just you add them, then order will come. Just you add. So what is the order of reaction now? Therefore, the order of reaction is 2 plus half sum of the powers. So the order of reaction is 2.5, 2 and half, 3. So 2 and half, 2.5 is the order of reaction. Order may be anything. So this is explanation I am explaining actually. See, means the sum of the powers of the concentration terms present in the rate equation, only rate equation. Then it is called order of reaction. I will give another examples also, series. This is a statement I have given, statement. In this also some conditions are there. These conditions everybody have to listen carefully. See, I am writing 2A plus 3B gives products. 2A plus 3B gives products. So rate equation, how to write? You can expect that the rate equation R equal to K into concentration of A square into concentration of B cube, because this power will turn to this power also will turn into B power cube. So now the order is 2 plus 3, 5 will come. Then it is the wrong answer. It is the wrong answer. Why it is wrong answers? That's why conditions are there. I'll tell you these conditions now. So if the question is given like this, write the order of reaction means you have to check for rate determination step or rate limiting step. Always rate equation you have to write for the rate determination step के लिए. If you have rate determination step, then only you are eligible to write the rate equation. Then in the rate equation only order you will get it. So rate determination step is very important point. What is that rate determination step? Rate determination step or rate limiting step is the slowest step of the entire reaction mechanism. In the entire reaction mechanism, slowest step you need to catch. For the slowest step only, rate equation you can write. This is one condition. Because fast, here the overall reaction is there. Suppose see, this is the overall reaction. In exams they will give, yes, for this reaction rate determination step is, suppose they put, for this reaction the rate determination step or the rate limiting step is A plus B gives products. Suppose if it is given, it means this reaction may takes place in several steps. Step number 1, 2, 3, 4, like that, several steps. We don't know now. We don't know about all those several steps, we don't know. Whatever the steps are there, out of all these several steps, slowest step मालूम होना चाहिए. They will give exams. Slowest step, suppose for this reaction, slowest step is this. Remaining all steps, इससे जोड़ा थोड़ा fast moving steps होगा. If the step is fastly moving, rate we cannot determine. We cannot determine the rate for this fast reactions. क्यों? Fast, if any reaction fast moving means आप लोग rate determination करने के टाइम के अंदर वो रिएक्शन कंप्लीट हो जाएगा. So fast moving reactions means we cannot find out the rate determining करने का पहले वो रिएक्शन कंप्लीट हो जाएगा. That's why slowest step only important here. For this slowest step only rate we can determine clearly. Suppose for this reaction, this is the given rate determination step or rate limiting step, means slow moving step. For this step only rate equation we can write, so that order we can find out. So for this slowest, this is called rate determination step, RDS. So then the rate equation we can write for this, R equal to K into concentration of A into B. Then how much is order? So the order of reaction is here 1, 1. So 1 plus 1. So 2. It is the second order reaction. Means don't depend on the given equation always. If the given equation is a rate limiting step, then okay. So don't depend upon always given equations. You have to check, is this a rate determination step or not. Then only the rate law you can write. So for the rate law only the order of reaction we can get. So this is the main important condition to determine order and to write rate equation. Rate determination step is very, very important. Now, so I will do some examples of order of reactions. You see once. Now actual chemical reactions I will give. See this. Suppose if PCl5 dissociated to form PCl3 and Cl2 is given. PCl5 dissociate to form PCl3 and Cl2. So for this rate equation we can write how? The R equal to K into, directly I am writing molar concentration of PCl5. Yeah, if it is the rate determination step, 1 mole only there. So 1 mole is there means it always rate determination step only होगा. So if it is 1 mole is there, we can write rate equation like this. So power 1, order you can write 1. So here order 1. So see here PCl5 gas, all these are gases are there. If the reactants are gases, so we can also write rate in terms of their partial pressures also. Always no need to write in terms of concentrations. In terms of partial pressures also we can write. How do you write the order of reaction? See, or R equal to K into partial pressure of PCl5. Yeah, like this way also we can write. So K into partial pressure of PCl5, like that. So here also order is 1, here also P power 1, so order is 1. So if pressures are given, then also we can find out the rate. How do you write now rate? Change in the pressure by change in time. Here change in the concentration by change in time. Here in terms of pressure, change in the pressure by change in time. So like this way also you can write the rate. So if the gases are given, you can calculate the rate with respect to their partial pressures also. Okay, you got the rate equation here, and we got the order. Order of reaction is how much now? The order of reaction is 1. Here important thing is K. Here K is called first order rate equation. K is known as first order rate equation. I'll give one more example. Now I am giving examples for the first order reactions. See this. These are the examples for first order reactions. Examples for first order reactions I am giving. Here some exceptions are there, including all exceptions I will tell you. ऐसा दे दिया तो easily you can find out yes it is the first order reaction. See for example, suppose see 2H2O2 is given. 2H2O2 dissociated to form 2H2O plus O2. How do you write the rate equation for this? The rate equation you can write like this: R equal to K into concentration of H2O2 power 2. If you write like this, you are doing mistake. Because here more than one is there, means there is a chance of multiple steps. Multiple steps are there means anyone should be slowest step. Then for that only you have to write rate equation. So here directly you are writing by considering this is only slowest step. This is a wrong process. If more than one moles are there, you have to think yes multiple steps are possible or not. If multiple steps are possible, then slowest step you need to catch. Then only rate equation you need to write. For the rate equation only order you can write. See, yes, it has multiple steps. I'll tell you. This is all I told you, exceptions are there. By looking at this reaction, it seems to be second order. It seems to be second order, but actually it is a first order reaction. See how it takes place, a mechanism now. In the form of mechanism, I'll tell you. See, in the mechanism, step number A, see, out of the 2 moles of H2O2, 1 mole is dissociated to form H2O and a nascent oxygen is given. H2O2 dissociate to form H2O and a nascent oxygen is forming. This is step number 1. Step number 2 is, out of the 2 H2O2, 1 H2O2 only I have taken here. Now the second H2O2 is there now. The second H2O2 gains this nascent oxygen. Forming again H2O, releases O2. From this oxygen and this oxygen, O2 is forming, remaining H2O is coming. Now the overall reaction is this nascent oxygen is cancelled. You will get H2O2 is 2H2O2. 2H2O2 gives here 2H2O and O2 comes. Yes, this is only overall reaction is given. Yes, this overall reaction only we got here. But it takes place in 2 steps. So which one is the slowest step, which one is the fast step? Let us decide now. See, the nascent oxygen, here this nascent oxygen is coming, no? In this reaction, nascent oxygen is coming. But nascent oxygen is the highly powerful oxygen atom. It is highly reactive. Highly reactive means quickly involving the reaction. So here the nascent oxygen involving reaction is a very fast reaction. Quick reaction is going on. So this is fast. So this will be slow reaction now. If it is fast means when compared to this is slow. As it is slow means this is we are considering as the rate limiting step, RLS, rate determination step or rate limiting step. So if you decide the rate limiting step, then you can write the rate equation now. For this only rate equation, so write it down. What happens? R equal to K into concentration of what? H2O2, that's it. H2O, because only one reactant is there in this, 1 mole of reactant, that's why mole concentration we have written there. So here power 1 is this, therefore order of reaction is how much? 1. So reaction looking like 2, like order is 2, but actually order is coming as 1. These are all exceptions. So if more than 1 mole of reactants are given, you have to think multiple steps are there or not. So all the chances, all the exceptions I am going to giving now. So these you just prepare it enough. So this is example 2, H2O2 case. So looking like second order but actually acting as first order, and this K is called as first order rate equation. See example 2, the same thing. See 2N2O5 dissociate to form NO2 plus O2. 4NO2 plus O2. 2N2O5 dissociated to form 4NO2 plus O2. Here also more than one is there. So you have to think, yes, it is order is 2 or order is 1. So mechanism. So step number 1. So this N2O5, you see wherever H2O2 reaction is given, its order is always 1. You have to remember like this. Hydrogen peroxide dissociation reaction seems to be second order but actually acting as first order. Here also N2O5 dissociating reactions are seems to be second order but actually acting as first order. I will explain the reaction mechanism for this also. N2O5 dissociate, it forms NO2 and nascent oxygen here also. 2NO2 and nascent oxygen forming here also. So 2NO2 and nascent oxygen forming here also. See what happens. In this case, if it is coming, this nascent oxygen is combined in the second step now. See in the second step, this one more N2O5 is there. This one more of N2O5 is combined with this nascent oxygen. It forms again NO2 there, again NO2 and releases O2 there. So from this one more oxygen releasing out and combines with this nascent oxygen forming O2. So the overall reaction here also oxygen is cancelled. N2O5 is 2N2O5 gives here N and N. So 2 to 4 moles of NO2 and oxygen is forming. So this N2O5 dissociated to form like this. This is only given overall reaction. It takes place 2 steps. Here also nascent oxygen involving. Nascent oxygen involved reactions are all fast, so it will be slow. So slowest step is the rate determination step. So let's write the rate for the slowest step now. Rate means rate equation. So rate equation, what happens? R equal to K into molar concentration of what? N2O5 power 1. So power 1 is this. Here also order equal to how much? 1. So it seems to be second order, actually acting as first order. It decides the reaction mechanism. It means based on these explanations, one point you can get it that order can be determined experimentally. Yes, we have to do these experiments. Order can be determined experimentally. Means you have to write, you have to find out the rate determination step. Determination can be done experimentally only. So rate if you want to write, or the rate if you want to write, slowest step is required. Therefore experimental determination only gives order of reaction, because rate equation means slowest step we will get experimentally only. So these are the reactions seems to be second order, but actually acting as first order. See, ऑर्डर एक्सपेरिमेंट डिटर्मिनेशन, अभी तक मैंने फर्स्ट ऑर्डर बोल दिया. ऑर्डर कैन बी जीरो ऑल्सो, ऑर्डर कैन बी वन, ऑर्डर कैन बी फ्रैक्शनल. आई गिवन बिफोर 2.5 ऑर्डर आ गया. ऑर्डर कैन बी फ्रैक्शनल, ऑर्डर कैन बी जीरो, ऑर्डर कैन बी 1, 2, 3, that's it. More than 3 order comes means those reactions will never be slow. So more than 3 means 4 moles, suppose 4 moles of any reactants are participated means they are not moving with slow speed. That's why experimentally fast is coming. So rate equation is not possible. Therefore order we cannot write, order we cannot calculate. So order can be 0, order can be fractional, order can be 1, 2, 3, and order can be negative also. One first order I told you already. Fraction also I shown. It is possible. Fraction order also possible. And order can be 1. 1 I had told you. Order can be 2, 3 also. So see, order can be 2. Second order. Examples for the second order के लिए I am giving now. Examples of second order. 0 I will tell you. After the second and third, 0 order I will tell you. Example for second order. You see 2HI dissociated to form H2 plus I2. This is possible. So order of this reaction on dissociation. So how do you write? Yes, 2 moles. 2 moles are there in this now. These 2 moles are having slowest step or multiple steps. ऐसा के लिए आप लोग देखो, ये है रेट डिटर्मिनेशन स्टेप. आप लोग कंफ्यूजन होने का जरूरत नहीं है. इन एग्जामिनेशंस दे विल गिव यस दिस इज द रेट डिटर्मिनेशन स्टेप. सपोज टेल मी दिस इज द रेट डिटर्मिनेशन स्टेप. Then rate equation, how do you write? R equal to K into concentration of HI power 2. Yes, it is second order. This is for decomposition. Now the formation of HI means reverse of this reaction. See, reverse of this reaction means H2 plus I2 gives 2HI. This is also second order reaction. If it is the rate determination step, then R equal to K into concentration of H2 into I2. H2 concentration into I2 concentration. H2 power 1, I2 power 1. So 1 plus 1, order is 2. So this K is called a second order rate constant. If order changes, K units also changes. I will tell you the rate constant units after completion of these examples. So in previous case, this is first order rate constant. This is second order rate constant. It is also second order rate constant. So like that, the examples for this second order we can write. Second order. So like that, third order also possible. Third order rate equation also possible. See, examples for the third order. See, NO plus O2 gives NO2 we can take like this. NO gas, O2 gas gives NO2 gas. Yeah, it is. If it is the rate determination step, they will give. Then the rate equation for this is R equal to K into concentration of NO square into O2. You may ask, sir, how do you know it is a rate determination step? They will give. So this is the slowest step of reaction. They will give. Yes, it is slow only. Why? NO, there is a covalent bond, it has to break the bond. O double bond, O also there, it is also has to break the bond. So I already told you, if more covalent compounds are there, that reaction will be slow only. So these are all the slow moving reactions only. Slowest step only going on here. So rate equation is this. Now the 2 plus 1, third order it is. So here the K is third order rate constant hoga. Third order rate constant. So first order, second order, third order is over. Now I will tell you the examples for the zero order. Zero order, how it is possible? See, I will tell you. Suppose A gives products. For this rate equation, let us write. If it is the rate determination step, so for this rate equation will be, so R equal to K into concentration of A. If you write power 1, first order. If you write power 2, second order. Power 3, third order. But here zero order. So which one we have to write? Power 0. Then only it will be zero order, right? So anything power 0. So whatever the value is coming, that is only order we are seeing like this. First order, second order, third order, we got like this. Fractional order also we got like this. So like that, if you want to get the zero order, the power should be 0 should come. Now the order will be 0. So order is 0 there. Zero order reaction. But how it is 0? If it is a 0, anything power 0 how much? 1. Then here R equal to K. It means for all the zero order reactions, rate become constant. That is a very simple thing. Means constant speed going reactions are all considered as zero order reactions. Means for all zero order reactions, power should be 0. Anything power 0 is 1. Therefore, R equal to K only should come. RK means rate constant. Rate equal to constant. Means constant speed going reactions. What are they? All natural reactions are all constant speed going reactions. What are they? Photosynthesis. Photosynthesis is taking place in presence of sunlight. We cannot increase the sunlight intensity, we cannot decrease the sunlight intensity. So, constant speed is going on photosynthesis. We cannot increase, we cannot decrease the speed of the photosynthesis. Or any reaction is taking place in presence of sunlight, they are all constant speed going on reaction. Means sunlight depend reactions are all. Some reactions are there in presence of sunlight only, those reactions takes place. In the absence of light, they won't undergo. Example, photosynthesis and other chemical reactions also there. Free radical mechanism reactions. The free radical mechanism reactions are all taking place in presence of sunlight. Means constant speed going on reactions. So they are all zero order. I will tell you why it is. See, example for this is photosynthesis I told you, and constant speed going on reactions means, see, H2 plus I2. This is I already given the second order reaction. This H2 and I2 is forming 2HI. This is I given in second order before. But this is only, this can also acting as zero order. How? If it is takes place in presence of sunlight. Yes, sunlight. In presence of sunlight, homolysis is going on. Free radical mechanism. Homolysis, equal bond breaking. So in presence of sunlight only it is going on. So constant bond breaking is going on. Constant bond forming also going on. So the speed of reactions constant means aega. Then it is considered as a zero order reaction. So how do you write the rate for this? Rate equal to K into concentration of H2 power 0 and I2 power 0 there. You can take Cl2 also here. Cl2, H2 and Cl2 gives 2 HCl. So you can write H2 and Cl2 power 0, power 0. Means constant speed going on reactions, free radical reactions, both these. So the here also R equal to K, you will get it. There are examples are there. Zero order reaction example. Zero order reaction doesn't mean that reaction participation is not possible. Here reaction participation is possible, but constant speed is going on. Means decrease in the concentration of reactants constant में जाएगा, increase in the concentration of products also constant में जाएगा. Constant speed means same extent decrease in concentration of reactants, same extent increase in concentration of products are going on. Then they are called zero order reactions. And another example for, see here whatever the K is there, this K is called zero order rate constant. It has some units also. These units also I'll tell you. And another example for the zero order reaction is, suppose see if any gas is absorbing on ammonia gas, is absorbing on any metal surface. Any metal surface, suppose in this gold metal area, any metal surface, gold ho, iron ho, any metal surface mineral area, it decomposes to form H2 plus N2, see, NH3, you can take 2 NH3 also, you get N2 and 3 H2. Actually if this gold, any metal surface is not there, it is a second order reaction. You can write here R equal to K into concentration of ammonia square, we can write. But if it is a zero order reaction, means it should be any metal surface should be taken. If this in presence of metal surface, the reaction constant speed में जाएगा. If this metal surface is not there, then it becomes a second order reaction. Yes, it becomes a second order reaction. So here in presence of metal surface, why it is zero order reaction? Why? Because see, metal surfaces, suppose if it is a metal surface, on this any gas is occupying. In metal surface any gas is occupying, it is constant speed में जाएगा. Why? Whatever the space is available on the surface, we cannot increase the space, we cannot decrease the space. So whatever its capacity, that much of gas only it can occupy. So that much of speed only going on. So here the capacity of available space, we cannot increase, we cannot decrease. That's why occupation is always constant speed is going on. That's why the rate also constantly going on. So that's why the product formation also constant speed only going on. This is called adsorption. It will come in the surface chemistry chapter. So adsorption topic is important here. So any gas is occupying on any surface, the constant speed is going on there. We cannot increase the speed, we cannot decrease the speed, because the space intensity we cannot do anything. It means if any surface is given this occupation, we cannot increase, we cannot decrease. That's why it is always going on with constant speed. So rate we cannot increase, we cannot decrease. That is why it is also constant speed is going on, therefore it is order is 0 there. Order is 0. So therefore for this also R equal to K will come. So photosynthesis reaction, next in presence of sunlight going reactions, next in presence of any metal surfaces gases are occupying, they are also considered as zero order reaction. So order can be anything. Order can be anything there. So 0, 1, 2, 3, it can be fractional, it can be negative also. These negative order reactions will come in the objective. There I will tell you, I will remind this point. Negative order, I will show this. So order can be determined experimentally. And here one more thing is, I have told you different K, zero order rate constant K, first order, second order, third order. What are the units of these rate constants? I'll show here. See, I am taking n moles of A gives products. Order is n moles, a general form of the units of K I am deriving. Now the heading is a unit of K. For this, when n moles of A gives products is taken, so order is n will come. How? If it is the rate determinist step, so you can write R equal to K into molar concentration of A power n. A power n we can write. So order is n there. Nth order rate equation is this. Nth order rate equation. So here the K is the rate constant for nth order. So we have to find out the unit of K for nth order. Order is how much here? N. Means general form I am deriving. So from this tell me that K equal to what? R divided by molar concentration of A power n. I told you in the yesterday's video value of R. What is R? R unit. R means change in concentration by change in time. Change in concentration, mole per liter per time. Let us take time is in seconds. Then you can take minute, year, hour, weeks or anything. Time. So R unit is mole per liter per second. Divided by, this is also mole per liter. It is a concentration of A. Concentration means nothing but mole per liter. So you will get mole per liter power n. So R means mole per liter per time. A means mole per liter power n. So what we can write? This is mole per liter power 1. This is power n. So let us move into the numerator. This value numerator will equal, then K is equal to mole per liter power 1. This is power n. ऊपर गया तो you will get mole per liter power 1 minus n. 1 minus n second inverse you will get. Mole per liter power 1 minus n second inverse. So this is, we can write it as, see, K is equal to mole power 1 minus n. Let us split this value into the numerator and denominator. So mole power 1 minus n into liter power divided by liter power 1 minus n. वो भी ऊपर लेके आए तो liter power n minus 1 second inverse. Yes, this is the unit of K for nth order. Mole power 1 minus n, liter power n minus 1 second inverse. It is the unit of rate constant for the nth order. If you take n equal to 0, means 0 order. What is the unit of 0 order rate equation? 0 order rate constant. See, for 0 order, n equal to 0. So n equal to 0 means what? This formula, K will be mole power 1 minus 0. Liter power 0 minus 1 means what will we get? Mole power 1, liter power minus 1, second inverse. This is nothing but mole per liter per second. It is the unit of rate of reaction. You see that rate of reaction R. R unit is mole per liter per second. Yes, we got it. Mole per liter per second. It is the unit of K for 0 order. It is also unit of the rate of the reaction. They'll ask this question, for which order rate constant units and rate of reaction units are same? 0 order के लिए. So K and R units are mole per liter per second for 0 order. Now for first order, n equal to 1. First order n equal to 1. What will be the unit of K? Mole power n equal to 1. 1 minus 1 liter power, here 1 minus 1 second inverse. then K equal to 0, this is 0 means second inverse. So this is the unit of K for the first order, just per time, per second. Now what is the unit of K for the second order? F n equal to 2, what will you get? K equal to mole power 1 minus 2 means minus 1, mean mole power minus 1, here liter power 2 minus 1 means 1 second inverse. So this is the unit of K for second order. If order changes, the unit of K also changes. Rate constant depends on, the unit of rate constant depends on order. If order changes, the value of K also changes. This is the general formula to find out unit of K. That's it. Different order of reaction. Order can be determined experimentally. Experimental means rate determination step you have to know. Then only order we can find out. Now the next topic is, after order is over, the next topic is molecularity of a reaction. Molecularity of a reaction. When you know the order, molecularity concept also together you have to learn. See, molecularity also another concept. To understand this one, I will give one simple explanation. See, I am taking 10 moles of A to form 1 mole of D. 10 moles of A become 1 mole of D. By looking at this reaction, we can get one idea that it is not a single step. It has some multiple steps. Let us write its multiple steps. Generalize karke I am explaining now. See, generally how do you understand this? Its mechanism I will tell you. Mechanism. See, in step number 1, 10 moles of A becomes 5 moles of B. Step number 2, B. So 5 moles of B becomes 3 moles of C. Step number C. So 3 moles of C become 1 mole of B. Yes. This entire reaction takes place in these 3 steps. On adding of all these 3, you will get this one only. 5B cancel. 3C cancel. So you will get 10 moles of A become 1 mole of B. Overall reaction you will get this one only. So by taking all these A, B, C reactions, you can decide that which one will be the slowest step out of all this. More the number of molecules means the reaction will be fast. So this will be faster than 5 molecules, than 3 molecules. Lesser the number of molecules means less is the concentration, so less is the rate. So this is the slowest step. This is the slowest step. So this is only rate determination step. So for this only rate equation we can write. So tell me, for this rate equation, R equal to K into concentration of C power 3. So it's a third order. Experimentally determined order. Order is 3. Molecularity also 3. Molecularity also 3. Order 3, molecularity 3. What is molecularity? Molecularity means the number of atoms or molecules or reacting species which are involving in the rate determination step of a reaction is called molecularity of a reaction. That's it. So this is a theoretical determination. Order is experimentally determined. Molecularity is theoretically determined. Means whatever the number of molecules or atoms or reacting species which are involving in the rate determination step is called molecularity of a reaction. In this case, 3 moles or 3 atoms. Number of atoms only, not moles. Here 10 atoms of A I have taken. Here 3 atoms of C are participated. So molecularity 3, order also 3. So here order 3, molecularity also 3. This is the difference between order and molecularity. Order can be determined experimentally, but molecularity can be determined theoretically. Look at the differences. Order means the sum of the powers of concentration terms present in the rate equation. Molecularity means the number of atoms or molecules or reacting species which are involving in the rate determination step. Order can be fractional, 0, negative, can be 1, 2, 3. But order cannot be 0. Molecularity cannot be 0. Order can be 0. Why molecularity cannot be 0? This is meaningless. Molecularity 0 means 0 molecules are participating in the reaction. It is meaningless. And molecule cannot be fractional. So fraction, half molecule is participated, half atom is participated, also not possible. Order can be 0, but molecularity cannot be 0. Order can be fractional, but molecularity cannot be fractional. Order can be 1, 2, 3 or anything, means 0 or fractional, but molecularity can be 1, 2 or 3 only. More than 3 also not possible. More than 3, order also not possible, molecularity also not possible. More than 3 molecules are participating means that will be fast reaction order. It will not rate determination step. That will be fast step order. So, order, molecularity, differences are like this. So, for the molecularity also, we have to take a rate determination step only. So, molecularity can be 1, 2 or 3. It cannot be 0, cannot be fraction, cannot be more than 3 also. This is about the molecularity of a reaction. So, like that, order, molecularity, we can discuss. So, this is about the effect of concentration on rate of a reaction. So, based on this, some questions are there, and after this, integrated rate equations are there. These integrated rate equations I will give in the next video. That's all today. Thank you.